representation of something I discovered while playing around on Google Earth. Now, I'm not making any claims. I'm just pointing out something incongruent. And I really don't like incongruency. Anyways, so here I am in Antarctica. As you can see, it's a large continent. I have a couple other pictures of Antarctica that I've discovered of the internet. Looks like this one's sonar. Of course, I could be wrong. I'm not a geologist. But you can see the mountain range, and you can see a sort of blurry area. But, you know, that could be any computer anomaly. There's nothing indicating that that's not accurate. You see mountain range that goes down to an ice shelf on either end. Okay, that's historically the Antarctica we've been shown. Here's another one. Looks like an elevation map. And again, you see the mountain range in darker red, and then slowly goes down to the ice shelf in the water. Okay, fairly consistent with what we've been shown as well. The problem that I'm having is when we come to Antarctica, there's a big white spot, but of course you can put that off as electromagnetic interference with the satellite. Really, that's not really conclusive at all. So we'll ignore that. So we continue to go on. We have this lovely elevation thing right here. And when we're in the water, we can clearly see we're in negative elevation. And when we're in the mountain, we can see we're in a positive elevation, which again would be consistent with the maps that I just showed you. So the interesting thing, though, is when you watch the elevation as I get more towards the center, it starts to decline. Okay, well, we're going to the shore. Obviously, it's going to get lower. As we get closer to those ice shelves, it's going to decrease. As you can see, it decreases all the way down to about 100 feet and maintains relatively 100, 120 feet of ice shelf to 150 feet until it gets to the sea level and it's negative. The interesting thing, though, is right here in the middle, as we come down, it's got a drastic elevation decline, all the way up until we get to 0 feet. 0 feet above sea level. That's quite interesting. Why we have a 0 foot, so it comes down gradually, 0 feet. 0 feet, 0 feet, and it starts increasing again. Now that's very similar to almost like a crater impact. We'll take a look at Wolf Creek here in Australia. You can see that it's got elevation, but then it goes into a lower elevation, and it maintains fairly level elevation, almost as if it were a crater, a pockmark. And also in Rim Drive Crater Lake in Oregon, you see the same phenomena where you, let's back out a bit here. You take a look at the elevation going up. So look here, the bottom of the feet, my elevation comes up, comes up, comes up, and then it starts going down, obviously, as it's a crater. But you notice, look at the elevation now, 6183 feet. It maintains a level balance because, of course, this is a crater. So for the whole lake, which in this case is only around 4 miles diameter, the whole lake is flat. Now here's interesting, a two-dimensional view of Rim Lake. You can see the foot profile, it decreases, and the whole floor is flat at 63,663 feet. As you traverse this lake, and you can see where it comes back up again. So that's indicative of a crater. So back to Antarctica. We'll close this. So here we are back in Antarctica, and you see this sort of outline of a circle. Again, possibly a computer anomaly. I'm not going to go on to what's that. But you see this from here. You can see the elevation goes from 0 into this other small mark, 0 across to 0, or that's almost 13 miles in diameter of a 0 elevation. That's very weird. Now, I'm not making any claims on subterranean entrances or whatever have you. I mean, I'm not going there. All I'm saying is it's clearly incongruent. So let's take a look at this the elevation view of this line across here. So you can see my arrow. Obviously, we're out into the ocean. So you see my elevation by this area right here. We're out into the ocean, and we come up to level with Antarctica. Okay, you've got a small mountain range right around there. And then we come in, and it gradually declines again. And so here we are at 0 feet. 0 feet to 0 feet. And that's about 15 miles of a 0 elevation diameter. Now, if this were a computer anomaly and it just returned a null value and Google Earth had to drop in some zeros just to make it render, I mean, I'm a computer guy. I understand that it's possible. But what I don't understand is how, if it was a computer anomaly, why would it have a decline to that point and then increase to that point, from that point? If it were just a computer anomaly, it would just be a null value, and you'd have a steep drop-off where the data was not collected. Very interesting. And now we take another look at the shelf. This is taken from a different angle. You can see where, let me zoom in a bit so you can see where I'm taking this from. This is from this larger circle right here. It decreases, it decreases, it decreases, and then voila, 0 feet for 13 miles. What on earth? And now, let's say it is a crater. Let's say it is a crater like Rim Lake in Oregon, Rim Drive Crater Lake in Oregon. If that's the case, then why don't they show it in our maps? Let me see what I don't see a flat surface 13 miles. I don't see where it's even decreasing in elevation to that point. That's incongruent. That's inconsistent. And here's another. There's no indication. This still shows red, still like it's a mountain, but it's clearly declining to a central 13-mile flat plateau, 0 feet above sea level. And that's quite interesting. 0 feet, which I don't know what to say about that. So, I mean, I've played around with paint.net. It's nothing fabulous. But I figured, what should it look like if it were a true manipulated image? So I have here, let me zoom in. I manipulated this image. This is not a factual image. But this is what, according to the elevation, this is more or less what this should look like. Because you can see it would decline up to that point and be actually lower in sea level than the ice shelf itself. Again, I'm not making any claims here. I'm just saying that it's incongruent. It's inconsistent with what we've been taught. So the question is are these images manipulated, or is Google Earth have bogus data? And if it's bogus, why? I mean, I can understand if this was a null value for the 0. I can understand if it was a null value. And from this way, it's even wider. This plateau, not completely circular. Anyways, I don't have the resources to make a 3D elevation map of this. I can only do 2-dimensional. I'm sure there's some other YouTubers out there have the resources to make a 3-dimensional elevation map to determine what's actually under this white washed out area. I'd like to see something like Rim Lake here, or Crater Lake, I'm sorry, in Oregon, where you can actually see the different elevations from the land. This would be sweet to see what's going on in the South Pole. But at this point, I don't really know what to say except that it's clearly incongruent, the data that we've got. It's definitely not mountainous range in this area, although what we've been given out there indicates it is all mountainous, and it's maintained this level all the way to the ice shelf, when in fact there is definitely a 0-foot level elevation, 13 miles in diameter at least, right there in the smack dab in the middle of the North Pole. Now, you can, if those want to say that it was magnetic interference on the satellite and returned a null value and was able to render and lift a black hole, okay, that's entirely possible. But it would be more of a let's go back to Crater Lake here. If that were the case, if it just returned a null value, then you would see, oh, I guess this is what we really need. You would see a drop-off like my computer's having some problems here. 1 second. That. Yeah, so as I was saying, if it were a null value, then you would see something more like this. You would see it continue to incline, but at this point where it finally received a null value, it would drop down to a flat nothingness. You wouldn't have a gradual decline of null value to a 0 value. It would be a positive value, null value immediately. That's how computers work. So because Antarctica has the level, the flat spot, the gradual decline, it would indicate to me that it wasn't just the null value return, but it was actually showing actual data of a flat surface, of a very flat surface, consistently flat surface. I mean, not even the Great Salt Flats in Utah are that consistently flat for that different amount of time. It's definitely an anomaly. You know, Thomas Jefferson said, you know, for here we are not afraid to follow the truth wherever it may lead. So it's interesting that the incongruency there. I'm not making any claims. I'm just stating an incongruency. The data clearly shows there's a flat plateau, 0 sea level, lower than the ice shelf, smack dab in the middle of Antarctica, with a gradual decline and a gradual incline with a diameter of around 13 miles. So if someone out there can take the whole area and put out a 3D elevation map, that'd be sweet to see. Well, I appreciate your time, and hope you guys find this entertaining. Look forward to any comments and feedback. Obviously, let's not be ridiculous and come up with ridiculous answers. Also, it's interesting to go to this nice little website that talks about Admiral Byrd's trip and a couple other things. Let's see if I can remember the website here. Oh, yeah, it's called, if you go to bibliotecaplayera.net, I can actually post the link, talk about the hollow earth. Quite interesting reading. I'm not claiming it's true. I'm saying it's interesting. I'll post this link as well. It's bibliotecaplayera.net in Tierra Hueca. You can see where that goes. All right, well, y'all have a great day, and I look forward to your comments. And let's try and shy away from the ridiculous.